Hey everyone. Today I want to talk to you about, I don't have a better word than symptom, that you may encounter. So a lot of people, most people never actually encounter this because you have to be doing certain things. I'm doing this because you have to be actively steering. You have to be doing certain things in order to experience it. And you will experience it on Hydros Plus with the 1 Series or the 2025R 2nd Gen. Or if you have a BX, you'll experience there if you do this sequence of events. But I'm telling you this because while you can do this with a stock 1 Series, it's very unlikely that you're going to notice it because it has to be at the lowest RPMs. And that'll make sense when I'm going to talk about the symptom here, and then I'll take you to the bench and show you the inside of the flow divider and what's actually happening. And then this will all make sense to you. But before I start yammering on, let me just show you what the symptom is. And well, I guess before I turn the tractor on and actually demonstrate it, let me talk a little bit about it. So it's going to be when you're actively steering, and it's going to be under a heavy load. And I'm going to simulate a heavy load by using the, on a deadhead, the bucket circuit. So I don't have a bucket on here, but you'll hear the tractor pull down. Now, this tractor is set to about 2,800 PSI, so when you do deadhead it, you're going to hear the engine pulling down. Your engine may not pull down quite that much, depends on what your hydraulic pressure is set to. And if you do increase your hydraulic pressure, you're more likely to run into this symptom than if you just leave it stock. Now, if you've been around very long, you'll know I'm a fan to at least turning it to 2,500 PSI, even if you add Hydros Plus cylinders. But that's just me. That's where I think the tractor does the best. And if you have the backhoe, there's some other things. But we won't get into that today. But let me show you the symptom. It's actively steering, and it's not when it goes under load. It's when it comes out of the load. So pay attention to that. I'm gonna talk, but you may not be able to hear me really well. So with this has a priority flow divider, so does the BX. That's why these are the ones that are affected. So it really doesn't matter the RPMs so much, but it does matter. But the reason it matters has to do with how it replenishes the fluid. I'll tell you about that on the bench. But for now, I'll give it a little bit of RPM here. And so I'm going to start steering, and this is set up like you would get it if you put Hydros Plus on. We set the flow divider at the factory at about 2 gallons a minute. And this is what your steering will feel like. It basically feels like it does when it's stock. So we're steering, we're having, no problem. Now I'm going to add some load. So I'm lifting something super heavy, or I can't lift it, or I barely can lift it. But you notice nothing changed. The steering is just as easy as it was before. But then if I abruptly let go of this for a moment, just for a second, now that may look exaggerated, but if you're actively steering and just for a second, it will lose. Basically what's happening is it's losing its hydraulic flow momentarily while it adjusts to the pressure. Now, if I go to a higher RPM, that actually isn't quite as abrupt. And also if I let off of the load more gently, you won't really even feel it at all. So again, you have to drive it almost in a certain way to feel this, but depending on who you are and what your driving style is, you may feel it a lot, or you may not feel it at all. So that is the symptom. And again, it has to do with the priority flow divider, which I'll show you what that means on the bench. But before we go in, what I'm going to do is give you a little bit of an overview, because it is relevant, of how the steering works on this tractor. So obviously you have the tires down here, and you've got a hydraulic cylinder that is moving the tires in the linkage, but there's no linkage from this steering wheel to that hydraulic cylinder. Now on a truck or a car, we know that we actually have a linkage a physical linkage that goes like a rack and pinion, as an example. You have a pinion that's on your steering wheel, you have a rack that it moves side to side, and then that moves your tires. In this case, we still have that same steering motion, but it's all created by this orbital control valve that is connected to the steering wheel, and then the hydraulic ram or hydraulic cylinder that's down on the steering. In the case of the John Deere, it's more of a standard one like you see on the loader. On the Kubota, which I think is a better approach for steering, it is one that moves in the center, and it's actually equal both ways. So on this tractor, if you were to steer to the left, it'll actually steer faster to the left than it does to the right. And it has to do with the different displacement you have between the bore side and the rod side of the cylinder. Now, most of us don't notice that, but that actually is what happens with the Kubota. It's actually equal regardless if you're going left or right, and then if you're going left. But here, what we're doing is we're actually pumping fluid. So even though there's no physical linkage to that, the orbital control valve acts as a pump, and we're able to steer with no power whatsoever. What powers the steering is the pressure from this circuit, but the reason flow matters on this is not because more flow creates more power or more easy steering. And that's really why priority flow divider works better here. What you actually need to do with motors and orbital control valves and pumps, when you think about the insides, the things that mesh together or that need to be connected, they're actually metal to metal. So if you look at a pump, it's two metal spur gears running together, right? And they're running kind of like this, but they actually take the fluid around the outside. So don't think that they push it through the center of the gears. But anyway, as these gears are moving, what actually seals them up is flow. The flow creates basically the gasket seal, and once you have enough seal, then the pressure can do its job. If you look at something like the hydraulic cylinder there, it actually, that's different than a motor because it has an O-ring that slides up and down that barrel, and that's what makes the seal. So you can actually operate a hydraulic cylinder at a super low flow. I mean, it may take a day to get to the top, but you can just, as long as the seal is good enough, you can just keep putting it in there drop by drop, and it will actually keep pushing and pushing and pushing. Again, there is some limitation to that, but you get the idea. It doesn't really matter how slow it is, assuming that the seal, the O-ring has a good seal. With hydraulic motors, that's not true. You put a drop in the top of a hydraulic motor and it'll find its way through all the little crevices and nothing moves. That's why we have minimum flows for things like motors, and orbital control valves, things like that, because we got to get enough flow trying to push through there that it basically seals things together, and then the pressure in the back can start to push. And that pushing is what helps us do the steering. So that's a steering in a nutshell. It's applicable to this because now we're going to go to the bench and I will tell you, or I will show you what's actually happening when we get this little hitch in our steering. All right, we're on the bench. As I mentioned, we've got a Hydros Plus priority flow divider valve, and this is the pretty side. Ugly side is here. As I welded a stick to it, and I used my bandsaw to cut it in half. Those pieces are gonna be here. It's just easier for me to think about it in this configuration. So before I explain the actual symptom as we've been talking about, let me tell you how priority flow divider works, so you understand kind of the anatomy of it, and then I'll talk about what's happening as you're steering, and then you let off of a load, or you basically go from a high pressure to a low pressure. I know it seems like it would do it when you go from low to high, but this is actually the reverse, and that's about to make a whole lot more sense. Now, this spring doesn't like me, so I want you to use your imagination and assume that spring is in there. In a normal configuration, this spool is pushed against this under spring pressure, and it's probably, I don't know, 5 to 10 pounds of pressure. It's pushing back this direction. Now, on this flow divider, and all priority flow dividers have something like this, where you have a single inlet. You have a priority side or a control side or a constant flow side. I've heard it called a number of different things. And then you have an excess flow. Excess flow may not have any flow at all. The only time the constant flow or priority flow doesn't have any flow is if you don't have any flow coming in. Now, one other thing I'll mention, and I said it earlier, well, let me say this. This is the, in this case, this is the variable adjustment. Now, not all priority flow dividers have variable adjustment. Some of them have a fixed orifice. This one has the seat valve, and we're able to adjust it from something like, well, basically zero. It won't quite be zero, but it'll be almost zero, up to maybe 12. I can't remember what the actual gallons per minute that you'll get, but something like 12. The whole valve is good for 30, but you can't get all 30 through the priority side. So this is the adjustable aspect of it, and it comes adjusted at 2 gallons a minute, and 2 gallons a minute looks like, let's see here, I'll go here. I mean, if this is seated, it's literally 1/4 turnout. So if you look at that, you really can't even see that there's a hole, but there is a hole. The amount of fluid that can go through a very small hole is always amazing to me. But this is our variable adjustment. So you've got our inlet, and you can see it's got a path to come through here. Now I'll pull this spool out. We've got this cavity here. Now this is really just circumstantial. They use this same casting for a number of different types of valves. So this may have a use, but it really doesn't have a use. In this case, it just comes in to this. Now with our spool end, since it's open on the end, this is basically one cavity if you think of it that way. This middle cavity is a separate cavity, and then this cavity is the excess flow cavity, and then this one does have a use. It actually works as a piston. So we've got a small hole here, this little orifice. We've got a pass through on the spool. We've got a pass through, main pass through, and inside here we actually have a plug. Now, if this was not a variable flow divider, let's see if I have we would have one that looks like this. You can see that has a hole in it. This one is like a 2 gallon per minute orifice there, and it would be in here and would let some fluid pass from the center cavity over into the priority cavity. But again, ours is different because it is variable. All right, as everybody probably knows, fluid's going to travel the path of least resistance. So let's talk about what does this thing do when we just put it on the tractor, we do nothing else. Now, you may not know this, but as you start your tractor, you've got, with Hydros Plus or otherwise, you've got some amount of flow. So stock flow is going to be, it doesn't come into this, but it would be like 6 gallons a minute going into the PTO manifold. But in our case, let's say we have a stage 3. So we have at startup something like 5 gallons a minute, and wide open throttle we're closer to 11. Just to make the numbers easy, let's just say we start it and we're at wide open throttle, right? So this is set to 2 gallons a minute. So what's going to happen is a whole lot of fluid is going to come in quickly, of course. And as it goes in, it's going to try to figure out what's the easiest way to go. Well, easiest way to go may be here, goes into this. Remember, there's a plug here. It's going to go in here and start to move into the end of this, and there's that small orifice there. But as it hits that orifice, it's probably a little harder than going up here for just a minute at least, because this seat valve is going to be more surface area than that small orifice there. And so it's going to come in and probably make its way here. And the first thing it does, it's got this spring here pushing it back. It's going to start going out the priority valve here. Now, at some point around 2 gallons a minute, if it's set this way, you're actually going to start getting back pressure, residual back pressure here. That's going to make it harder to go this direction for some of the fluid than it is to go to this direction and even out that orifice. Now, as it goes into this hole here, it'll fill up this pocket through the spool, but then it's going to start going through that orifice, and this becomes a piston, and it's going to start overcoming the spring pressure here. Now, right at 2 gallons a minute, it's going to be probably right about there, right? So 2 gallons a minute, say if we only had 2 gallons a minute, it would look like this, and no flow would be coming out of this excess flow. But of course, we have a lot more than that. We've got about 9 gallons a minute after the 2 gallons of here. So now 9 gallons a minute's got to pour out this direction. So that pressure, again, this is going to work almost like a piston. It's going to use the inside of that as well as far as part of its surface area to move. And then it's going to push this open to where the rest of the flow of the 11, 9 can actually go out the excess flow. And that's what it's going to look like, sitting there at wide open throttle doing nothing else. Now, as this opens more, you'll notice that this is also closing. So it's basically equalizing those pressures based on the setting and what residual pressure happens here. It's going to, find its equal. So as we start steering, residual pressure is going to build up here, and it's actually going to make it harder for fluid to go this direction. Because of that, this fluid is going to be a little bit less pressurized, and it's going to open this up more so that more fluid wants to go here, so we can maintain our 2 gallons a minute to the steering. So as you're actively steering, you're going to see this, well, if you were able to see it, you'd see this valve constantly trying to adjust to these different pressures on each side. So what happens when we have the hitch in our steering, right? So RPMs don't matter as much. I said that they don't, or I think I said that they don't, but the replenishment could matter a little bit, but a lot of fluid's going through here. So if you're sitting here in the same situation, you've got 9 gallons going this way and you've got 2 gallons going here, and then you add 3,000 psi or 2,000 psi on this side, what happens is the same thing with the steering. As it starts to push back, it's going to increase the hole on this side because it needs more to push against the 2,000 so we can, well, actually, it doesn't think like that, sorry. It will start to push this direction because what happens is the fluid will pressurize all the way back to here, and it's going to force more fluid this direction. Well, because of that, it's basically going to restrict on this side. And the way that happens is what I was talking about. You have more pressure here. It's going to push out through this orifice, and it's going to squeeze that down, right? So as I deadheaded the loader, this is what's happening. But that's okay because this 2,000 psi pressure pushing back through here, we're still getting our 2 gallons a minute. You can steer, no problem at all. But as soon as I abruptly let go, just for a moment, what happens? You got 2,000 psi coming this way, and then you have 100 psi. Well, 100 psi isn't enough pressure to continue this flow through here and through that tiny orifice to get my 2 gallons per minute. For a moment, it might drop to 1.5 or 1. I don't actually know what the flow would drop to. Maybe it drops to almost nothing because it just so abruptly stopped. Everything is going to go this easy path now because this is a very tight orifice. But as fast as the fluid can go back through this tiny little hole, this pressure is going to equalize. This spring is going to push it back, and we're going to open up this hole and replenish the flow to the steering, so we've got our 2 gallons a minute. So that's why it goes, it hitches, and then it keeps going. It doesn't stay that way because it just takes one, maybe not even a full second for this to open back up, the fluid to go to the steering, and you're off to the races. Now, as I mentioned, in the orbital control valve, the flow does not do the work, the pressure does the work. But if there's no fluid, there's no pressure, and things also may not be completely sealed up. I think it's really less about the sealing of things, and it's more about the fact that no fluid's really flowing for just a brief moment, and then it's flowing again, and you can start to steer again. So that is what is happening if you have a priority flow divider. It does not matter whether it's a Hydros Plus equipped tractor or Kubota BX or some other piece of construction equipment. If you do it in this way, then, and you abruptly stop, that equalization of the pressure is always going to have that effect on the priority valve. There may be machines that have a whole lot of residual pressure where if you did that, it doesn't go all the way back to like 20 or 50 or 100 psi. Maybe it goes back to say it's 2,000 here, maybe it goes back to 1,000 or 1,500. That may not be as obvious when that happens because these won't be so far out of whack. But going from 2,000, 2,500, or 3,000, whatever you got your tractor set to, that is an abrupt change. And when you do that, you're going to have a little bit of time to recover. So that's it. Maybe one last thing to mention, the more pressure you have your tractor set to, the more you're going to feel this, right? So if you think about if you had 3,000 PSI back pressure and you let off immediately, so it goes way over here and you just get this little tiny crack, and then you abruptly let off, it's going to take, time, it's going to open up again. But if you only set to 1,800 PSI, which most people are probably a little higher than that, then this orifice is not going to close off quite as much, and you might recover a little quicker. It may not be as abrupt. But again, this is not something that is harmful, and you can change your driving style so that you don't run into this. I'm not saying that's the solution to it. I'm just saying if it's something that happens and it really bugs you, that would be one way to adjust. You can also add a little bit more flow to the steering, because if you have 3 gallons versus 2 gallons, the how this recovers is going to be just a little bit different, because this is already going to have to be open a little bit more, even under 2,000 or 3,000 PSI. But I don't really think that's the solution. 2 gallons a minute is plenty to run your steering. As long as it doesn't feel tight, that's where you should run it. I think you should run it to the minimum of how you like it. That way you get more performance through your excess flow and through your implements. But that's my opinion. You're certainly welcome to run it however you like. But I hope that answers the question. If there are further questions or comments or anything you want to mention, leave it below. And thanks for watching.